Alright guys, so today we're going to talk about how to solve word problems using quadratic equations. As you can see here, we have our notes with two examples. The first one says the product of two consecutive even integers is 48. Find all sets of these integers that satisfy this description. So the important things we need to see there is that we're looking for all sets, and these are two consecutive even integers. Product is a good important word. It means we're going to multiply. And the product is 48. So first step, it says to write a let statement. That's what we have here. Let the first consecutive even integer be x and second one be x plus 2. What I'm going to call that is define your variables. That's what I would prefer you do. So you're going to define variables. And all that means is tell me what your variables are. If you don't tell me what they are, I don't know what they are. So we have translate the problem into an equation. So what we have here is x times x plus 2 equals 48. Distribute the x, you get x squared plus 2x equals 48. If you subtract 48 from both sides, you get x squared plus 2x minus 48 equals 0. Factor that, you get x plus 8 and x minus 6. And when you solve those, you get x is equal to negative 8 and x is equal to 6. So our two factors are either negative 8 and negative 6, or 6 and 8. Those are our consecutive even integers. Now it doesn't specify positive, so we want to keep with both positive and negative. Make sure you list all answers. Same thing here, we have the length of a rectangle is 4 less than twice its width. Area is 70 square meters. We want to find the dimensions. So we know that area is length times width. Our length is 4 less than twice the width. So our width is our x, and our length is 2x minus 4. Our area is going to be 2x minus 4 times x equals 70. 70 equal, subtract 70 from both sides, factor it, and solve for x. We get x is equal to 7 and x is equal to negative 5, and we reject the negative 5 because you can't have a negative side. So those are the steps right there. You can follow them step by step. Let's go ahead and do a couple of examples. So the first one we have is the product of two consecutive odd integers is 99. So remember our keywords here are product, and we need consecutive odd integers, 99, find the integers. So I'm going to define my variable. My first integer is going to be x, and my second integer is x plus 2. And the reason it's x plus 2 is that they are consecutive odd integers. So if I went from 1 to the next odd integer, that would be 3. So 1 plus 2 equals 3. So we're looking at product, so we're going to put x, our first integer, times our second integer, and that's going to be equal to 99. We're going to have x squared plus 2x equals 99. On this one, guys, what I would do is I'd go ahead and complete the square. That's going to be our easiest method for solving because b is even, and anytime b is even, we can complete the square. So remember, to complete the square, we need to add b over 2 squared. So our b is 2. 2 over 2, quantity squared, is 1. So we're going to add 1 to both sides. And that gives me x squared plus 2x plus 1 equals 100. Now, if you watch our video about completing the square, we know that the next step is to write our trinomial in factored form, which is x plus 1 squared equals 100. And we're going to take the square root of both sides, giving us x plus 1 equals plus or minus 10. Subtract 1 from each side. And that's going to give me x is negative 11 or positive 9. So those are our first integers, negative 11 and 9. If we add 2 to each of those, we get negative 9 and positive 11. So our solutions are either negative 9 and negative 11, or simply 9 and 11. It didn't specify positive, so we need to have both answers. So the next one we have, find two consecutive positive integers, positive, such that the square of the first decreased by 17 equals 4 times the second. So the first thing we're going to do is, of course, define our integers. So our first will be x, and our second is x plus 1. All right? And so we want to be that the square of the first decreased by 17. So what we're going to have is the square of the first decreased by 17 is equal to 4 times the second, which was x plus 1. And now we're just going to simplify. So we're going to have x squared minus 17 equals 4x plus 4. And I'm going to move everything to this side, and I'm going to see what that does for me. So I'm going to subtract 4x and 4. So we have x squared minus 4x minus 21. 21 equals 0. And again, because b is even, it's fairly easy to complete the square. So remember, we want b over 2. First, I'm going to go ahead and add the 21 to both sides, because I need just my x squared minus 4x equals 21. And then I'm going to add negative 4 divided by 2 is negative 2. And if I square that, it's 4. So I'm going to add 4 to both sides. And then we get x minus 2 squared. And I'm going to go ahead and skip to the trinomial, equals 25. Okay. So if we have x minus 2 squared equals 25, take the square root of both sides. We get x minus 2 equals positive or negative 5. Add 2. And that gives me x equals negative 3 and positive 7. But it says positive, so we don't care about that negative 3. Okay, so we have 7. So if our x is 7, x plus 1 equals 8. So our integers are 7 and 8. And remember, anytime the problem is given to you in words, you should give the answer back in words every single time. All right, let's try another example. The length of a rectangle is 5 meters longer than twice its width. The area is 33 meters. Find the dimensions of the rectangle. So the important things we need to know is we're looking at a length is 5 meters longer than twice its width. Area is 33 square meters. So let's go ahead and make a list of what we know. Area is 33 meters squared. Length is 5 meters longer than twice the width. Now we know that area is equal to length times width. So we're going to go ahead and write this in terms of width. So we're going to have our 33 equals our 5 plus 2w times w. And now we're going to go ahead 33. One moment, guys. Okay, so we have 33 equals 2w squared plus 5w. And then we're going to subtract 33 from both sides. Because b is not even, this is not a good one to complete the square. So I'm going to go ahead and put my 0, and I'm going to have 2w squared plus 5w minus 33. And I'm going to actually go ahead and solve this one using the quadratic formula. So remember, our quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac. All of that is over 2a. Always write your formula. Okay, so we're going to go ahead and go make our list. Our a is 2, our b is 5, and our c is negative 33. So we're going to go ahead and plug our a, b, and c into our formula. So we have negative 5 plus or minus the square root of 5 squared minus 4 times a, which is 2, times c, which is negative 33. And all of that is over 2 times 2. So next we have negative 5 plus or minus square root of 25. And then we're going to have negative 4 times 2 times negative 33. And that is negative 4 times 2 times negative 33. Use a calculator for this. So plus 264. Because we have a negative and a negative, so it becomes positive. All of that is over 4. X equals negative 5 plus or minus the square root. And this is going to come out to, when we simplify the radicand, it's going to be square root of 289 over 4. And the square root of 289 is 17. So we're going to end up with x equals negative 5 minus 17 is negative 22 over 4. Negative 5 plus 17 is 12 over 4. We need to simplify. So that gives me negative 11 over 2 and 3. And remember, we don't care about our negative answers because our width can only be positive. So if our width was our x, because that's what we solved for w, our length will be 5 plus 2 times 3. 2 times 3 is 6, plus 5 is 11. So our dimensions are 11 meters and 3 meters. And we should write that again in a complete sentence. So the dimensions are 11 meters and 3 meters. One more example. Go ahead and we have another rectangle question. The length of a rectangle is 7 units more than its width. So length is 7 more than its width. If the width is doubled and length is increased by 2, the area is increased by 42. So we're going to find the dimensions of the original rectangle, not the new one. Wait for it to clear. There we go. So we're going to write a series of equations. So first of all, we have our area of our first rectangle. So I'm going to call that A1. That's our first length times our first width. Our first length is first width plus 7. So our new area for A1 is going to be W1 plus 7 times W1. And then if we have our new length, so our length 2 is equal to, we're going to increase it by 2. So it's L1 plus 2. And then our width 2 is going to be 2 times our original width. So that means our length 2 is W1 plus 7 plus 2. So that is W1 plus 9. And that's going to be our length 2. And our A2 is A1 plus 42. And it is also 2W1 times W1 plus 9. So now what we're going to do is we're going to substitute this for A1. We're going to substitute the original A1 in for the new A1 in the new one. And then we're going to substitute in the A1, or this second equation, A2, for A2 here. So what we're going to end up with is 2W times W plus 9, notice I'm going ahead and drop the 1, is equal to W plus 7 times W plus 42. Okay, I'm trying to get it to clear up. One moment. All right, so we're going to go ahead and distribute. We're going to have 2W squared plus 18W is equal to W squared plus 7W plus 42. And again, we can go ahead and solve this multiple ways, but let's go ahead and get everything together on one side of the equal sign. So I'm going to move everything to the left-hand side. So I'm going to rewrite up here, 2W squared plus 18W is equal to W squared plus 7W plus 42. And I'm going to subtract W squared, I'm going to subtract 7W, and I'm going to subtract 42, all in one go. Okay, so W squared minus, or 2W squared minus W squared is W squared. 18W minus 7W is 11W. Oh, yes, 11W. And then minus 42. That's going to equal 0. 11 is not even, so I would not do this one by completing the square, but this one can be done by factoring. It's pretty simple. First thing we're going to do is factor our negative 42. And we're going to ask ourselves which factors of 42 can subtract to give us 11. So we have 1 and 42, 2 and 21, 3 and 14, and 6 and 7. And the one we're going to use is 3 and 14 because we want positive 11 with subtraction. So our factors are W minus 3 and W plus 14. Set each of those equal to 0. And solve for W. So plus 3 and minus 14. And focus. Okay. And that's going to give me W equals 3 and W equals negative 14. And again, we can't have a negative width, so we don't care about the 14. We only care about the original width of 3. And our original length was W1 plus 7. So if W is 3, length is 7 plus 3, and that's 10. So the original dimensions are 7 are 7 and 3. And they didn't give us specific units to care about here, so we're just going to leave it as 7 and 3. All right? So I know sometimes this was a little hard to focus on. The light didn't work out so well. But if you have any questions, feel free to go ahead and leave them in the comment section down below, or you can ask me in class. Either way, send me a message, let me know what you need, and I will get this done for you. All right, and if you care to find out when I upload new videos, go ahead and like and subscribe. I don't care, though. Have a good day, guys. See you next time. Bye.